list. So what was done? So he arranged the elements in the increasing order of the atomic weights, and so that every eighth element, okay, what he found that the every eighth element had similar properties to that of the first element. So this was the law given by Newland. So this is called as Newland law of octaves. So that is octaves of music, right? Sa, re, ga, ma, pa, dha, ni, sa. So the sa of the starting and the last, so it resembles the same. So the first element and the eighth element, the properties were similar. Okay, so it is called as the law of octaves. Octaves means eight. Okay, so the first element and the eighth element, it had the similar properties. So it is called as the law of octaves or octaves of music. Okay, so these were resembling the octaves of music. So later there were next scientists called as the Lothar Meyer. So there were studies going on. Okay, the studies were going on with the studies. Okay, how the elements were discovered by the scientists. Okay, the studies were going on. So next scientist who was studying about the elements was Lothar Meyer. So he studied from 1830 to 1895. Okay, where he studied it from 1830 to 1895. Okay, so what he did? Okay, he arranged the elements in increasing order of their atomic weights. So what he did, he arranged the elements in their increasing order of the atomic weights. So what he discovered that the similarities in their there were similarities in their physical as well as chemical properties at regular interval. Okay, so at regular interval there were some uh, similarities, okay, between the same elements. So he plotted a graph. So he plotted a graph wherein physical properties such as atomic volume, melting point, and boiling point. Okay, so these were the the physical properties which he took. Okay, and he plotted the graph of atomic volume, melting point, and boiling point against atomic weight. Okay, and what he obtained, that he obtained a periodic repeated pattern. So repeated pattern was obtained. Repeated pattern means what? It showed that repeated pattern means what? They had some similarities. Okay, after such certain interval of time there were similarities. Okay, there were certain similarities. So what it shows you that some of the elements, they are okay, some elements when you're arranging according to the atomic weights, some of the elements are resembling to the each other. Okay, so they have some same physical and chemical properties. So they have what? They have similar physical and chemical properties. Okay, so this was the study done by Lothar Meyer. Okay, so what Lothar Meyer did, he arranged the elements in increasing order of the atomic weights. Okay, so there were some similarities. Okay, so similarities were found between like the physical and chemical properties of the some of the elements were resembling. So these physical properties of some of the elements, okay, after a certain period of time they were repeating. So this was the graph and study done by Lothar Meyer. So after Lothar Meyer, so this also failed after few time. Okay, so he could not arrange the next elements. Okay, so he could not arrange the next elements. So this study was restricted only for few elements. Okay, so this study was restricted only for few elements. So later, what happened? There came another scientist who was Mendeleev. Okay, so Mendeleev's periodic table. So till Mendeleev started studying about the periodic table, what happened? So there were many elements which were discovered. Okay, so there were many elements which were discovered. So what was Mendeleev's periodic table? Okay, what was his law? So okay, so the physical property, he gave the law that physical and the chemical properties of the elements are the periodic function of their atomic masses. Okay, so before this, all the scientists who were studying about the periodic elements, what they said that all the elements, okay, so similarities, that is the elements are arranged based on their similarities in atomic, that is increase in the atomic masses. So Mendeleev also considered the same, and he said that the physical and the chemical properties of the elements are the periodic function of their atomic masses. Okay, so the elements with the similar characteristics. So when you're arranging the elements with the increasing order of the atomic masses, so the elements which are having the similar characteristic were present in vertical rows. Okay, vertical rows, and these rows are called as groups. So vertical rows are called as groups, and horizontal rows were called as period. Okay, so this was the terms used in terms in the time of Mendeleev's. Okay, so vertical rows were called as groups, and horizontal rows were called as periods. So this was the no I okay. So Mendeleev, what was Mendeleev's periodic law? The properties of the elements are the periodic function of their atomic masses. Okay. So when he arranged the elements with similar properties, so the elements with similar characteristics were present in vertical rows, and these were called as groups, and the horizontal rows were called as periods. Okay. So this also failed. So Mendeleev's periodic law also failed. Then there was a scientist called Moseley. Okay, there was a scientist called Moseley. So he was an English physicist. Okay, he was an English physicist. He showed that the atomic number is more fundamental property of a element than atomic masses. So till now, whoever scientist came with the study, they were studying in terms of their atomic masses. Okay, so till now, Daubernier, okay, Newland, then Lothar Meyer, Mendeleev. So these all studied the elements in the with their properties of atomic masses. So what they did, they arranged the elements with the increasing order of atomic masses. So this was a periodic function which they used. The, the English physicist Moseley, what he said that atomic number. Okay, so atomic number is a more fundamental property of an element than the atomic mass. So this is more, what you can say, most prominent. Okay, prominent. So atomic number is playing more prominent role than the atomic mass. Therefore, the position of an element in the periodic table, it depends on what? It depends on atomic number and not on atomic mass. So Moseley, okay, he said that atomic number is playing a important role than the atomic mass. So the position of the element in the periodic table, it is depending on the atomic number and not on atomic masses. So again, Mendeleev's periodic law failed. Okay. So because atomic number should be considered, so this law was modified. Okay. So this law was modified, and the law was given as modern periodic law. So what was the law? What does the law state? Modern periodic law states the physical and the chemical properties of elements are the periodic function of their atomic numbers. Okay. So what was periodic modern periodic law? The physical and the chemical properties of elements are the periodic functions of their atomic numbers. So this was the modern periodic law. Okay. So based on this modern periodic law, so the elements were arranged in in 7 periods. Okay, it was arranged, the elements were arranged in their increasing atomic numbers. Okay, so these were classified into 7 periods. Okay, and 8 groups. So vertical were periods, 7 periods vertically this way. Okay, 7 periods, and like this horizontally 8 groups. Okay, horizontally 8 groups, and like this 7 periods. So this was according to modern periodic law. Okay, so this was modern periodic law. So the modern periodic law, Okay, you can see this. You can see the periodic table. So this was a periodic table. So this was a periodic table. Okay, so this depends on what? This depends upon the increase in their. So this is based on the increasing. So modern periodic law. Okay, so the physical and the chemical properties of the elements depends on the okay, are the periodic function of their atomic number. So these are called as what? So these are called as the groups. Okay, so, sorry, periods. You can see this. These are periods 1, 2, 3, 4, 5, 6, 7. So 7 periods and 8 groups. So these are the 18 groups. Sorry, 18 groups. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 groups and 7 periods. Okay, so these was the what you can say classification. Okay, so this is how our periodic table looks. Okay, now based on this, so the periodic table. Okay, okay, so the main group. So the main group of the elements. So they are so there are 4. So it is divided into 4 sections. Okay, it is divided into 4 sections. That is S block, P block, D block, and F block. Okay, so based on this, they are divided into S block, P block, D block, and F block elements. Okay, so hmm. So here you can see what are S block, P block, D block. Then we will study in brief about it. Okay, so here this is the S block element to the left side. See that. Okay, so these are the S block elements. Again, I am sharing the periodic table. Okay, so first we'll see the periodic table and then we'll go for the brief detailing about that. Okay, so these are the S block elements. Okay, these are S block elements. S block. Okay, S block elements. Then these are the P block elements. These are the P block elements. Okay, block elements. Then these are the D block elements. So these are D block elements. And here, okay, these two are the F block elements. F block elements. So the periodic table, okay, so as there are so many elements present in the periodic table, so the periodic table is divided into 4 different groups. Okay, S block, P block, D block, and F block elements. So like this, as there are 118 elements, okay, so we cannot study each element separately. Okay, so we are going to study in the blocks. Okay, so these are divided into 4 different groups: S block elements, P block elements, D block elements, and F block elements. So we are going to study in detail and we are going to study its properties. Okay. So first we will study about the S and P block elements. So S and P block elements are together called as main group elements, or they are called as representative elements. Okay, so S and P block elements are together called as what? They are called as the representative elements. Okay, so S block elements, so the left side which we had seen in the periodic table, the left side. Okay, so these are consist of group 1 and group 2 elements. What they consist of? They consist of group 1, that is called as alkali metals, and group 2 are called as the alkaline earth metals. Okay, so group 1, they have what? They have SN1, they have SN1, okay, SN1 as the outermost electronic configuration, SN1 as the outermost electronic configuration, and group 2 are having SN2 as the outermost electronic configuration. So what is the main point here? S and P block are called as main group elements, or they are called as representative element. What does S block consist of? S block consists of group 1 and group 2. Group 1 are called as alkali metals, group 2 are called as alkaline earth metals. Group 1, what is the outermost electronic configuration? SN1. And group 2, what is the outermost electronic configuration? NS2. Okay, so we'll go for the next one. Next group, that is P block elements. Okay, next we are going to go with the P block element. So what are P block elements now? So they belong to group 13 to 18. So group 13 to 18 are called as the P block elements. Okay, what they are called as? They are called as the P block elements. The outermost electronic configuration is NS2 NP126. So this is the electronic configuration of P block elements. Okay, the outermost electronic configuration of P block element is what? NS2 NP126. So you need to remember what does P block consist of and what is the electronic configuration. Okay, H helium. Okay, helium is 1s2, is a S block element, but it is positioned with the group 18 element. So helium, it is the electronic configuration is 1s2. Okay, but and it is a S block element. So helium, it comes under S block element. Okay, but it is positioned with the group 18 element, that is NS2 NP6, because it has completely filled valence shell. As a result, it exhibits the properties, characteristics of the other noble gases. Okay, so these are about the P block elements. Next, we are going to study about the D block elements. So next is D block elements. So D block elements are called as the transition elements. What they are called as? They are called as the transition elements. So they are the elements from group 13 to group 12 with the general electronic configuration N-1, D 1 to 10, and NS 1 to 2. So this is the general electronic configuration. So what are the general electronic configuration of D block element? N-1, D 1 to 10, NS 1 to 2. Okay, so there are 4 transition series. So transition elements, they are having 4 transition series, that is 3D, 4D, 5D, and 6D transition series. So there are D block elements. So there are more number of elements as compared to other. Here, so they are divided into 3D series. 3D because the last electron will occupy the 3D orbital. Okay, so it is 3D. Then if it enters the 4D, then it is called as 4D. If it is entering the 5D, then it will take the 5D series. If it is entering into 6D, then it is 6D. And the 6D series is incomplete. So the 6D series is incomplete. What will happen to atomic radius? Atomic radius. Okay, atomic radius generally decreases. So when we are seeing about the, when we are studying about the atomic radius, so atomic radius generally decreases across a period and increases as we go down the group. So as we move across the period, we are going to study in the further periodicity. Okay, so that is when atomic radius, what will happen as you go across the period, it decreases. As you go down the group, it increases. So as you go down across the period, why it decreases? Because of effective nuclear charge. Okay, as you go down, okay, from left to right. Okay, what will happen? The force of attraction between the nucleus and the outermost electron will it will pull. Okay, because of effective nuclear charge, that is, the nucleus will tend to pull the outermost electron more tightly. As a result, the size will go on decreasing. Okay, then as you go down the group, why the sizes go on increasing? Because there is addition of new shell. Okay, because of addition of new subshell, as you go down the group, the size go on increasing because there is addition of new subshell. Okay, and the force of attraction between the nucleus and the outermost electron go on increasing. So as a result, the size also go on increasing. Okay, so this is the reason. Then F block elements are called as the so next is the F block elements. Okay, next is the F block elements. This F block elements are called as the inner transition series. Okay, they are called as the inner transition series. So they consist of 2 One is lanthanoids, another is actinoids. Lanthanoids, they are they are the elements in which the electron will enter into the 4f orbital. Okay, so they are from lanthanum. Okay, lanthanum following are the elements following lanthanum from cerium to lutetium. Okay, cerium to lutetium are the lanthanoid series, and actinoids, why they are called as actinoid? Because the last electron will enter into the 5f orbital. Okay, and these are the elements following the actinium from thorium to lawrencium. Okay, and the outer general electronic configuration of f block elements is n minus 2, f 1 to 14, n minus 1, okay, d 0 to 1, and s2. So this is the general electronic configuration of f blocks elements. So we have seen the periodic table is divided into 4 groups. We have studied about F block, P block, D block, and F block elements. Okay. So, and we have seen the general electronic configuration also. So based on this, we'll solve some MCQs, then we will go further. Okay. So this is the first question. Okay, so this is the first question. Periodic classification of elements is used to examine the A, periodic trends in physical properties of elements, B, periodic trends in chemical properties of elements, and C, both A and B, and D, none of the above. Yes, how the classification of elements is done? Based on what? So periodic classification of elements is used to examine what?
The question is not visible.
Okay, just a second. I'll share it one more time. Now, is it? Yes, now you can see. Okay, so this is a question. Periodic classification of the elements is used to examine the A, periodic trends in physical properties of elements, B, periodic trends in chemical properties of element, C, both A and B, and D, none of the above.
C, both A and B.
Both A and B.
Yes, so it is C. So the law, okay. So it the physical and the chemical properties of the elements, okay, it depends. Okay, it depends upon the so when you are arranging the elements with their increasing order, okay, so it depends upon the physical and chemical properties of the elements. So physical and chemical properties of the elements are the periodic functions of their atomic numbers. Okay, so it is option number C. Yes, it depends on both physical properties as well as the chemical properties. We'll go for the next one. Okay. So Cl, that is chlorine, bromine, iodine. If this is Doberanier's triad and the atomic masses of chlorine and iodine are 35.5 and 127 respectively, what is the atomic mass of bromine? Okay, so we had studied about Doberanier's triad. So what he said, that he arranged the elements in the set of 3. Okay, he arranged the elements in the set of 3 based on their similar properties. What he did, he arranged them in increasing order of the atomic masses. He took the average of first and the third, okay, and he added it. He took the average, okay, and what he got the mass, okay, he got the mass which was close to the,
Option C 81.24.
okay, so how we are going to do this?
35.5 plus 127 by 2.
Yes. Okay. So you are going to take the average of the first element. So this is the first element and the third element. So the atomic masses are given and then you are going to divide it. So average means what? You have to add the 2 and divide it by 2. So you get 81.25. Okay. So it is option number C. So this is the atomic mass which is close to bromine. Okay. 81.25. So option number C is the right answer. Good. So we'll go for the next one. If the two members of Doberanier's triad are phosphorus and antimony, so the third member of this triad is A, arsenic, B, sulfur, C, iodine, D, calcium. If the two members of Doberanier's triads are phosphorus and antimony, then which is the third member?
Not option A.
Option A. Okay. So what it is? It is arsenic. Okay. So the two members are phosphorus, antimony, okay, and arsenic. So these are the members of the Doberanier's triad. Okay. So for this, you need to know the what you can say atomic mass. Okay, atomic mass. What you can do, atomic mass of phosphorus and antimony, you can add up, you will get the third member, that is arsenic. So if you found out the atomic mass of the, okay, after taking the average, you will get the atomic mass. So this you have to see which it resembles. So it will be for arsenic. So it is option number A. So we'll go for the next one. The law of triads is applicable to a group of. So to which group it is applicable? Law of triads. So law of triads is applicable for which group? Carbon is 6. Okay, 6. Sorry, atomic masses. Twelve. This is 16. So if I take 12 plus 16 divided by 2, this will be 28 by 2. 2 ones are 2 ones are 2.
4 sir.
4s are 18. Okay. So this will be 14. If I take for hydrogen, this is 14. Okay. So if I add 14 plus 1 divided by 2, so this will be 15 by 2.
Ma'am, option B.
Sodium. Sodium is what? Sodium is
22.
Yes, it is 22. Okay. So 22 plus rubidium,
40.
atomic mass.
80.
It is 85. Okay, it is 85 divided by 2. So just see how much you'll get. 22 plus 85 divided by 2. So this will be 53.5. What is potassium's atomic mass? Potassium
39. 39.
atomic mass. It is
39.
39. So it is not applicable. Okay. This also it is not applicable. Then we'll see for chlorine.
Chlorine 35.5.
35.5. Then iodine is 127 divided by this 2. Okay. So this also, I think here two answers are coming. 35.5 plus 127 divided by 2. So it will be 81.25. So this is also close to bromine. Okay, bromine. Yes. So I think there are two answers here. It is applicable for this also.
Ma'am, option B and A.
So there are two here. Okay. So the law of triads is applicable for a group of, okay, A and B. So there are dual answers in this question. So we'll go for the next one. In 1800, only dash elements were known. Here X refers to how many elements were known in 1800? In 1800, how many elements were known? In 1800, only
Option
31
B.
elements were
31.
known. Okay, only 31 elements were known in 1800. So we'll go for the next one. Johann Dobriner gave the idea of trends among physical and dash of several groups of 3 elements. Here dash refers to. So based on what idea of trends he gave? Physical and atomic number, chemical properties, atomic mass, or
Atomic mass, madam.
Atomic mass, ma'am. Option B.
Dobriner, how he arranged based on physical and what properties?
Chemical properties.
Yes, it is chemical properties. Okay. He arranged the elements. Okay. What he did, he arranged the elements in group of triads based on their similarity in properties. So what properties they were? The physical and the chemical properties. Okay. Then based on that properties, that is physical and chemical properties, he arranged them in their increasing order of their atomic masses. So it is chemical
Both
properties. Option number C. So we'll go for the next one. So like this, the confusing questions will be. Okay, next. So here they have given the atomic masses also. So which of the following is the correct set of elements to Dobriner's triad? So you have to, what you have to do now? You have to add and see which is the correct set here. Okay. So if I take lithium, so what I have to do? Take 7 plus 39. Okay, then
Option
divide.
M.
Okay, divided by 2. So it will be correct. So first one is, it is showing 23 only. Okay. Then next one, if I add 80 plus 127 divided by 2, it is 103. So this is wrong. Then the next one, 55.85. Add with cobalt, that is 58.93. Okay. Divided by 2, it is 57.39. So this is also wrong. Data insufficient, wrong. So it is option number A. So the correct set of Dobriner triad is option number A. That is lithium, sodium, and potassium. So when you're adding first, that is the lightest and the heaviest element, you are getting the atomic mass which is close to middle element. So it is atom A. So we'll go for the next one. So on which of the following Brownian triad law is not applicable? So which of the following triad, okay, which it is not applicable? Chlorine, bromine and iodine, calcium, strontium, barium, okay, fluorine, chlorine and bromine. Okay, so chlorine, I'll just give you. So chlorine is 35.5. Okay, chlorine. Bromine is what? Bromine is 120. No, 39.
Option C, not applicable.
Yes. Not applicable. Fluorine is 18. Okay, fluorine is 18 and bromine is
80, ma'am.
80. Okay, just see now 80 plus 18. 80 plus 18 divided by 2. 98 by 2, what you will get? Iodine is 127. Calcium is 40. Barium is 137. Okay, then it should come of strontium to be 87.6. Just check for all. Okay, I'll just give you the atomic masses. Then lithium will be 7. Sodium will be 23. Potassium will be 39. Okay, now you can just have an idea. So if I, okay, you said for fluorine, C option. So I'll just see 18 plus 80. Okay, then divided by 2. So it should come for 35.5, but it is not coming. So it is not applicable for this. If I take chlorine, chlorine is what? Chlorine is 35.5 plus iodine is what? 127. Okay, divided by 2. This is coming for 81. Okay, this is okay. Then last, okay, so it is not applicable for C. Okay, it is not applicable for C. Option number C. Yes. So we'll go for the next one. Newland could classify elements only up to. So till which element could Newland classify the elements? He could only classify the elements up to calcium. Okay, option number C. So he could only classify the elements up till calcium. So option number C. Okay, so option number C is the answer. So option number C. Newland, he could classify the elements were restricted only up to calcium. So the law of octaves was only possible up to calcium. That is, next question. According to Newland theory, when elements are arranged in the order of increasing atomic weight, which number element had similar properties to first element?
Ma'am, option C, 8th.
Yes, it is option C, 8. So first and 8th element were having similar properties. Okay, so this was the law of octaves. Law of octaves. Okay, so we'll go for the next question. So yes, it is first and the 8th element had the similar properties. Next one, Lothar Meyer plotted the physical properties such as atomic volume, melting point, and dash against atomic weight. So your dash refers to A, mass, B, boiling point, C, surface tension, D, none of this.
Option B, boiling point.
Boiling point, ma'am.
Yes, it was. So he took the physical properties such as atomic volume, melting point, and boiling point. Okay, and boiling point against what? Against atomic weight. Okay, so these were the plot he had taken. So we'll go for the next one. The most significant contribution towards the development of periodic table was made by. So who gave the most significant contribution? Mendeleev, Avogadro, C. Dalton.
Ma'am, option A, Mendeleev.
Yes, option A, Mendeleev. So Mendeleev's contribution was most significant, okay, towards the development of modern periodic table. So we'll go for the next one. Noble gases were included in Mendeleev's periodic table in the, so in Mendeleev's, okay, not in modern periodic table. So it was included in Mendeleev's periodic table in which group? First group, seventh group, eighth group, or none of this?
Ma'am, 7th group.
None of this, ma'am. 18th group is noble gases.
Noble gases. Even I'll confirm. Noble gases, okay.
18th group noble gases.
Ma'am, 7th group, ma'am. In Mendeleev, 7th group, ma'am.
Question is wrong, ma'am.
Yes, no. See here in Mendeleev's periodic table, okay. What is that? In Mendeleev's periodic table, the noble gases, okay, so they were included in 0th group, okay, in 0th group. They are talking about Mendeleev's periodic table, okay, not about modern periodic table. In modern periodic table, it is placed in 18th group, okay, 18th group. So next question, Mendeleev's classified elements in A, increasing order of atomic group, B, 8 periods and 8 groups, C, 7 periods and 9 groups, D, 8 periods and 7.
Increasing order of atomic group.
Okay, so Mendeleev, he classified the elements how? He classified the elements in increasing order of atomic group, okay. So we'll go for the next question. The molecular formula of fluoride of Aka aluminum and Aka silicon respectively are. So what is the molecular formula of fluorides? So it is given as what?
Option C.
Yes, aluminum chloride and silicon chloride. So it is option number C. Okay, it is option number C. So last question. Who developed long form of the periodic table? Who developed the long form of periodic table? A. Lothar Meyer, B. Niels Bohr, C. Mendeleev, D. Moseley.
Ma'am,
Ma'am,
option
option
B.
Option?
D.
Option B or D?
Option D.
Yes, Moseley. Okay. So Moseley, he gave the long form of periodic table. Okay. Last one question. At present, how many elements are known? A, 110.
Option D.
Option D, 118.
Yes, 118 elements are known. So at present, we know 118 elements. Okay. So, okay. So, which of the scientists given below discovered that periodic table should be based on the atomic number? A.
Ma'am,
Mendeleev.
option C, Henry Moseley.
Yes. B. Newland, C. Moseley, and D. Lothar Meyer. So he was Moseley. Okay. He said that the periodic table should be based on atomic number. Okay. So the remaining MCQs we shall discuss in the next class. Thank you. Today's session was very interesting. I hope you enjoyed it. Yes.
Thank you.
Yes. Okay. Okay then. So we shall meet in the next class. Thank you. Have a good evening. Okay.
Thank you.